All right, so if you guys could tell me those values again. You said how much?
34.
34.
41.
41.
44.
44.
46. 81. 91. 93. 87. 78. 109. 101. 89.
All right. So we're going to take these values right here. I'm going to put them into a statistical piece of software, into an applet. There is a way to do this on the graphing calculator. However, for what we're doing today, it will show us both the scatter plot and the residual plot at the same time on this particular piece of software that I'm going to use. So I'm going to pull that up. You guys have access to this too on our page for today. Here's the applet right here that I'm using. All right. So our explanatory variable, what was our explanatory variable? Pullback distance. Is this not working now? Oh no, because it's not plugged in, that would be why. There. Pullback distance. And the values that we had for that, we did 2, 2, 2, 2, and then 4, 4, 4, 6, 6, 6, 8, 8, 8. And that was all of our input for our explanatory variable. What was our response variable? Distance traveled. Now we're going to enter those values. So we had 34, 41, 44, 46, 81, 91, 93, 87, 78, 109, 101, and 89. Let me double check, because if the numbers, yeah. We had 12 trials here, so we should have 12 outputs. If it doesn't match, it's going to throw an error. Stop. 1, 2, 3. No, go back. I want my numbers. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Begin our analysis. All right, guys. First thing I want you to sketch where it says linear plot. Make a very simple sketch of this. We're looking for the overall shape here. So we have our scatter plot, we have our residual plot. I'm going to scoot this up just a little bit so that residual plot can show up a little bit better. We just want this residual plot. I don't care about the dot plot on the bottom. We want this residual plot right here. This also gives us the equation for our regression line down here. The equation for our regression line, you'll want to copy this down. Y hat equals 26.1667 plus 9.6667x. And it tells me that my r squared is 0.754. R squared is 0.754. Do I need to leave the residual plot up, or can I get kind of this little box up a little higher? Okay, I can leave it up. Down here in this little box is where the equation is. Y hat equals 26.1667 plus 9.6667x. And R squared is 0.754, 75.4%. So only about 75% of the variation or the differences that we saw in those distances traveled can be accounted for by the linear relationship with how far we were pulling it back. That's what R squared tells me. Do you guys feel like that's a very high R squared or a very high R value?
Yeah.
I mean, I wouldn't classify it as weak. I'm curious if another model would be stronger. I'm going to try a quadratic model next. For the quadratic model, if you look at your page, what does it have that ordered pair looking like?
X squared.
X squared and then y, right? So for those input amounts, for the pullback amount, we're going to take all of those values and we're going to square them and then run this regression again. So instead of 2, 2, 2, I'm going to have what? 4, 4, 4, and then 16, 16, 16, 36, 36, 36, 64, 64, 64. I'm going to take all the x's, all the input, all the explanatory variable amounts, and I'm going to square them. Make sure everybody gets our residual plot. You need the equation and you need R squared. We're going to be looking at these residual plots and our scatter plots to try to find the best model. So this would be our linear model example. You guys okay if I change it up?
What's the equation?
The equation is y hat equals 26.1667 plus 9.6667x. Let's see if I can get that one a little bit bigger. I don't know if it'll let me. Oh, it will. Good. So there's our equation. You want to make sure to get R squared written down as well. So far, so good? All right. I want to see what happens when we try a quadratic model. So for my quadratic model, I'm going to leave the response variable amounts the same. I'm going to change all of these to be the square of what they are now. So 4, 4, 4, 16, 16, 16, 36, 36, 36, 64, 64, 64. Let's see what that looks like. There's the scatter plot when we square those values. Here, I'll put that back down in a minute. I want to calculate our correlation coefficient. So we want to get another scatter plot drawn here. Our R value for our quadratic model is 0.821. When we squared those x's, did that make our correlation coefficient stronger or weaker? Made it weaker. That's not always the case, but that does lead me to believe that a quadratic model is probably not the best here. Want to get our scatter plot in there. I'm going to go ahead and put the line of best fit, our least squares regression line in here. So there's where our least squares regression line falls using squared inputs. get our residual plot up here too. If you end up needing more space for your sketches, the previous page, I think it's 19, has nothing on it, it's just blank. So you could do sketches on the previous page if you need some more room. Let's get our residual plot on here. You guys okay if I put the residual plot up higher? So there's our residual plot. There we go. Our R squared value for this is 0.674. R squared is 0.674. What did we do to all those inputs again? Squared them. So here, instead of just this being pullback distance or x, that's pullback distance squared. We had x squared when we ran it this time. For those of you that are ready to copy down the equation is y hat equals 47.5233 plus 0.882, and then it wouldn't be x this time, it would be x squared. The equation doesn't tell me that because the equation doesn't know that I squared that input data. I know I squared it, so I know it should be x squared there. Do I still need the residual plot up? And I'm okay if I do. Right. Sounds good. I want to make sure I'm not going too fast. I just keep snapping pictures of it. So again, our R squared here is 0.674. Remember, the interpretation of R squared is that this is telling me that about 67.4% of the variation that we're seeing in that distance traveled, the changes in the distance traveled, can be accounted for by this quadratic relationship. I'm going to put this up just a little bit higher in case anybody else needs to record the equation or the R squared. Equation is right here. Remember, it should be x squared, not x. So y hat equals 47.5233 plus 0.8992 x squared. For this last model, I'm going to need some audience participation. The last model that we're supposed to do is what kind of regression? Exponential. What does that ordered pair look like for us? X log y. So I'm going to go back to our original input amounts, 222, 444, 666, 888. But now for each one of those output amounts, we're going to do the log of that number. So I'm going to need some help from around the room. You're going to need your calculators for this. Do I need to leave this up anymore? All right. go back and run our last regression, and then we'll determine which one is the best model and how we know. So I got everything changing here. Back to our original inputs, our original x's. 2, 2, 2, 4, 4, 4, 6, 6, 6, 8, 8, 8. I need the log of 34. 1.53. I need the log of 41. 1.61. The log of 44. 1.61 again. Log of 46. 1.66. Log of 81. You said 1.91. Log of 91. 1.96. Log of 93. 1.97. Log of 87. 1.94 you said? Log of 78. 1.89. Log of 109. 2.04. Log of 101. 2.00. And log of 89. 1.95. All right, let's see what this looks like. There's our scatter plot. There's the scatter plot of our data. Correlation coefficient, our R value is 0.858. Let me go ahead and put our least squares regression line in the back here. There we go. So there's our scatter plot with our least squares regression line. See if I can't fit our residual plot up at the same time. Won't let me get any smaller than that. All right, down at the very bottom is the residual plot. My explanatory variable on my x-axis is still pullback distance. That's just x. What did we do to our outputs, though? What did we do to all those output values? Log. So this is log of the distance traveled. That's what we have on our y-axis this time. We took the log of all those values. Why do you think I took the log of everything if we said we're doing an exponential model? What's the relationship between logs and exponentials?
That's what's named from algebra?
Yeah, they're inverses of each other. They undo each other, yes. So there is a very close relationship here between logarithms and exponentials. So when I look at this residual plot, I didn't notice it as much in the others, but this residual plot, other than this one guy that's down here, I see kind of an arc pattern to it. Do you guys see that? When I see a leftover pattern in my residuals, that is an indication that it is a good model or is not a good model. Not a good model. So there's a couple things that I want to be looking for as I select the best model. One of the things I'm looking for is the residual plot. I don't want to see any kind of leftover pattern. On this one, again, except for that one guy that's down at the bottom, I see a leftover pattern here. The other thing that I would be looking for is the highest R squared value. I haven't pulled up our R squared on this one yet. I'm going to get our residuals a little higher on the screen. All right, there's our residuals. R squared on this one is 0.729. 0.729. Which one of these three models had the highest R squared? Our linear model. Most of the time that's not the case. A lot of times with pullback cars it's going to be different. This particular one, apparently the only one my daughter was unable to break, has a very linear relationship with pullback distance. There's a lot of cars, I don't know if you guys played with these much as kids, but you'll pull them back a certain amount and it starts to click like it doesn't actually pull back further than that. I felt like we started to hit that right at the 8-inch one. A lot of them will hit that sooner. And then the distance traveled, it's going to go and then it's going to kind of lose steam as it's moving. And so you'll see more of a curved shape to that scatter plot. Our equation this time, what did we do to all of our outputs, all of our y's? We took the log. So instead of y hat, I have log of y hat. Let me get that up on the screen for us. Log of y hat equals 1.5167 plus 0.065x. Were there any of the other residuals that had kind of a pattern to it? We saw a pattern with this one. Were there any of the others that had kind of a leftover pattern? What was our linear model looking like? What was our residuals there? I don't have it up on my screen anymore. That one looks fairly randomly scattered. I don't see the same kind of arc. I see a little bit of an arc, but not quite the same. So again, things that I want to be looking for, highest R squared and no leftover pattern in my residuals. With those two things in mind, what do you think our best bet is on this one? Linear model performed the best. So answer to question number one, at least for ours, is a linear model. When I post the notes, I did this at home with a different car that didn't belong to me. It was a neighbor kid's car. So I collected some different data with that one. I'll show you a different model there as well if you want to get into the notes and look at what's another similar situation, but with different output. How many inches would you predict that we need to pull this back if we want the car to travel exactly 80 inches? How would I find that? I don't just want to look at my scatter plot, I want a prediction.
Plug in 80 for your y.
Yes, let's plug in 80 for y. Can somebody read me what our linear model was again? We had y hat equals 667, and then we're going to plug. Oh, just two sixes? Sorry, thank you. It was three? Okay. I don't think it'll make a huge difference in our calculations here. We're trying to make a prediction about pullback distance. If the finish line is 80 inches away, I'm going to put that in for y. So I want you guys to go ahead and calculate that. about how many inches does the model predict we would need to pull it back? 5.57, right about. All right. Let's get our big ideas written down for today. We don't have time to do the check for understanding. But I did want to go over this today because tomorrow I'm actually going to be out of the building for professional development. You guys are going to try to find the best model for Barbie. This is one of the pieces in the packet, but do you guys remember at the beginning when we did the Barbie bungee?
Yeah.
I want you to try to find the best model, and we're going to try to figure out how many rubber bands it would take for her to have the most fun and safest bungee jump. And then we're going to test that when I get back on Thursday. So I'm going to bring back the same dolls on Thursday that you guys used in your Barbie bungee. You will have your work from tomorrow. Try to find the best model, linear, exponential, or logarithmic, to model her bungee jump, because we want her to travel as far as possible without smashing her head against the ground. So we're going to try to predict how many rubber bands, and then we will go and test this. So remember, for our quadratic model, you're going to feed the information into the applet, only you're going to square the inputs and then run your model. For the exponential model, you leave your inputs, your explanatory variable, as the original data, but you're going to take the log of all of your outputs to get your exponential model. Okay. In addition to working on predicting what is the best model and how many rubber bands you think it's going to take for your particular doll that you used in that original bungee jump, I will also have the review for the test available for you guys tomorrow. The sub will pass that out. If you guys absolutely need to get a hold of me, Canvas message me. I'm going to be doing a virtual conference, so if you message me through Canvas, I will be able to respond back to you. Okay? If you are stuck on anything or you don't understand, I will try my best to leave detailed directions on Canvas. So when you get into class tomorrow, any additional directions, you'll click on that big blue button that says click here for today's lesson on our main page, and any directions that you need will be there. All right? Let me know if you guys have any questions.